Hello everyone, I hope you were doing okay with the slope fields packet. Some of these problems are a little bit more challenging than others, but I do plan on going over each one. So please let me know if you have questions by emailing me at any time. Let's take a look at these. All right, so for 8 and 9, 8 we have dy over dx is equal to 2x plus 1. So I take each x value. Notice I color coded them here so you could tell I also have them written, the values down here. So I'm just taking each x value, so that's why the columns are all the same color here. So when x is -3, all of the slopes here are going to be -5, 2 times -3 plus 1. Looking at x equals 0, 2 times 0 plus 1 is just going to give us 1. And then at the far right, when x is 3, 2 times 3 plus 1 will give us 7. So for any x value, these are the slopes, or what dy over dx is equal to. For number 9, now it's dy over dx is equal to y plus 1. So I'm going across the rows here. Horizontally, all the slopes are going to be the same. So for instance, when y is 3, dy over dx is going to be 4. Jumping down here, when y is -1, dy over dx would equal 0. So underneath, I have the work algebraically to find the solutions. For 8, a little bit easier. All we have to do is multiply both sides by dx. Take the integral of each side, combine our constants, and we end up with y equals x squared plus x plus our constant here. And we could kind of tell just by matching this here. Notice we don't see any horizontal tangents. We know 2x plus 1 is going to equal 0 when x is -1/2. So if I had that number, all of these would be the horizontal line segments. And then if I were to draw a curve in, it would look something like this. So that tells me getting a function of y here that is quadratic, looks like it matches here. All right, for 9, we're looking at dy over dx is equal to y plus 1. So I want to keep that y plus 1 together and then just divide both sides by it and multiply both sides by dx. Take the integral of each side, so this becomes 1 over y plus 1. We get the natural log of the absolute value plus our first constant equals x plus our second constant. Combine our constants, and we've seen this throughout quite a few problems here. And then we take our base e, and again at this point, e to the x plus c we rewrite as e to the x times e to the c, which becomes our a. To get rid of the absolute value, we say y plus 1 is equal to a times e to the x, or -a times e to the x, and then we simply subtract 1 from each side. So going back up to make a sketch here of the curves, we have two possibilities. Again, starting with the horizontal lines here, I could start and perhaps go up this way. That would be the positive a, or down here would be the negative a. All right, on the next two pages, we were matching, and actually the 10 through 17 could have been a bit more of a challenge than the others because all of these here showed us dy over dx. So what we had to do was take our functions, figure out our curve to help us figure out our function or the degree of our function, and that could help us determine our derivative or perhaps come up with very good guess of what a function could be and then take its derivative. So I know we did number 10 as an example, but I just want to talk about it again. Here, if we were to sketch in a curve, it looks like it's quadratic. So if we're saying y is quadratic, then dy over dx, its derivative is going to be linear. So we're looking for any dy over dx to equal some linear function. And we had a couple choices here. We had a, e, and f. But if you look here to help us out, if we're looking at e, which it was, all we have to do is say, well, when x is what value, we're going to get 0 when x is 2. So if we took a look at all of these here, this is where our horizontal tangent lines are, and then that matches. So that's what is really making e stand apart from the other two, because all we'd have to do is pick any x value, and if we got the opposite or if we got the same, then it could be a or f. But e was saying that y equals 1/2 x minus 1, and that's what matches. All right, looking at 11, if we were to draw in a line or a curve here, it is a line. So we definitely know that y is linear, so that means dy over dx should be a constant. And all these little line segments here have a negative slope, so we're going to say dy over dx has to equal a negative number, and the only option for that is a -1/2, which it looks appropriate here. So this is J. So hopefully you guys are coming up with that. All right, for number 12, now we just saw this with number 9. So even though we could say that for instance, maybe y is equal to an e to the x, but to go in this direction, e to the negative x would work as it's decreasing as we move from left to right. So then y prime, I'll just write it this way instead of dy over dx, that would equal e to the negative x times a negative 1. So that's going to equal negative e to the negative x. Below, this could possibly be y equals negative e to the negative x, and then y prime would equal negative e to the negative x times the negative 1, which turns into positive e to the negative x. So really what's happening here is if you take a look at its the derivative of y and y, even down here, they're opposites of each other, right? So y prime is going to equal the opposite of y. So we're looking for dy over dx to equal a negative y. And that happens with choice G. And one thing I do want to point out, notice with these, it was dy over dx is equal to something involving a y. If we go back to number 9, see what gave us the two separate ones, dy over dx was equal to a y and something that was being done to it. There was no x over here. And then when there is an x, we definitely just get either quadratic, cubic, or linear, or constant. So anytime we're looking at the separate exponential functions here, dy over dx is going to contain a y with it, so that was G. Now for 13, this looks like something that we really haven't spent a lot of time trying to graph by hand. And if you guys remember number 7 from yesterday, didn't it look like this, where we sort of have a curve that's going in one direction, and then if we move a little bit over, we don't get that same pattern that's taking place. So number 7 yesterday, dy over dx was equal to an expression that contained both an x and a y. And if you look at our choices here, the only option that has that is h. So that dy over dx is equal to y minus x. This we would need our calculator to help us solve and graph that differential, or graph the function from our differential equation here. So even if you saved 13, maybe you went through and tried all the others and then process of elimination, that is perfectly fine. All right, for 14, we only get one curve, and this looks like an exponential curve. So if we were looking at maybe just y equals e to the x, perhaps, because we have a couple choices here. Anything, actually we don't. So this one, y equals e to the x, we know that y prime is also equal to e to the x, so that's actually doing that for us here. So dy over dx is equal to e to the x, gives us b for that one. All right, for 15, this definitely looks like a sine or cosine function, so a periodic function. So we have two choices here, C and D. So let's say if y was equal to sine x, then y prime would equal cosine x. Or what if we said it the other way around? If y was equal to cosine x, then y prime would equal the opposite of sine x. Well, we don't have the opposite of sine x as an option here, so it has to be this one. So dy over dx is going to equal cosine x, so that was choice D for this one. This was another possibility, but it didn't show up, so we'll say not a choice. But it very well could have been. All right, looking at 16. 16 looks a lot like 12. Now 12 had dy over dx equal to something with a y. So if you go back and you look at all of our remaining options, the only one left would be I. And it does look like it's a little bit more stretched out. So I'll still go through the same kind of work that we went through earlier. So let's say, if it looks a little bit more stretched out, let's say y is equal to 1/2 e to the x. Then y prime would also equal 1/2 e to the x. So then we could say y prime is going to equal 1/2 of what y is here. And I say that with 1/2 y because even though this whole thing is y prime equaling y is not an option, but y prime equals 1/2 y is, so we're very close with how we were thinking of it. So again, this would actually be connected, but since this was not a choice, we're going to the next best one. So y prime is equal to 1/2 times y. All right, so for 17, this one should be pretty basic compared to most of these that we just went through. Here, y is quadratic. Therefore, dy over dx should also be linear. So if we're looking at some choices, we have the only two left are A and F. And if we're looking here with A, that it has to equal X. So if we're at 1, we should be seeing a positive slope. But if you notice, all of these slopes where the X values are positive are actually negative. So dy over dx is going to equal the opposite of X, which actually gives us choice F. All right, so I know that was a lot to go over. Please go back and review these. Make sure that you check and correct these a couple times to fully understand them. All right, and then the next page here, a little bit easier because all of these are just looking at what y is. So all the answers at the bottom start with y equals. So for 18 that we did, again, that was D. That was y is equal to negative x. And again, all you have to do is pick a value. So, so pick a value for dy over dx and then just see what that equals. Or we could just draw a line in here and we see that this looks like it has a negative slope. So that's why we were saying for 18, that was d, that y is equal to negative x. For 19, y is a periodic function. So if we look at our choices here, we have either G or H. And based on where this is right up here, we're looking at y equals cosine x. Because we know y equals sine x will go through the origin. All right, for number 20, it looks like y is quadratic. So if we go to look at our options, and we know this parabola opens down, so we're looking for a coefficient that's negative. In our choices, we only see one quadratic, which was e, and that's y equals a negative x squared, and that's definitely one possibility there. All right, for 21, based on how I have this drawn in, I just wrote it off to the side. This would be a nice rational function. So for 21, we're looking at perhaps y equals 1 over x. So this was I. All right, looking at 22, again, this looks like it's an exponential function. So guessing y equals e to the x would not be too bad. And that is the correct answer here of J. Based on the curve I have drawn in here for 23, this looks to be cubic. So if we go and look at all of our choices here, there's only one that's cubic, which is f. Y equals, they're just saying 1/2 x cubed, but that's the only cubic function we see. All right, 24, y is a constant. So if we're looking here, our two constants that we have are a, y equals -2, b, x equals 2, but that would be a vertical line. So a for 24. And I just have a horizontal line drawn in anywhere, but again, y equals -2 would fit in there. All right, now for 25, it's very similar to y equals e to the x, but this is actually the inverse. So we're looking at y equals the natural log of x. But we know we can't take the natural log of a negative number. So if you notice, it does have the absolute values. So k is the correct answer for 25. Y is equal to the natural log of x. So as I mentioned just on the last page, take your time, go back over these again so you fully understand them. All right, for this next problem here, I actually have the work on the following page, so I'm going to keep going back and forth here. But we're given the differential equation. All you guys had to do, notice there's not too many points here, but to fill in on the axes provided here, it does say 12 total points, so all we have to do is these 6 points and then below as well. So we have to take each point here, an x and a y, multiply the x by 2, divide it by y, take the opposite of that. So just showing you what that looks like. So again, just at these 6 points up here and then down here. If you wanted to, I just wrote them out off to the side here, just showing you the calculation for each one. So all 12 points. All right, so for question B, a little different here. Let y equals f of x be the particular solution to the differential equation with an initial condition f of 1 is equal to -1. Write an equation for the line tangent to the graph of f at 1, -1, and use it to approximate f of 1.1. So just to show you the work for that one, you'll also see part C here. All right, so since we want the equation of the tangent line, the slope of the tangent line, which again is still why did that skip back up? Let's go down. All right, so at 1, -1, the slope of the tangent line, which is dy over dx, so even using part of what I have written here for part C is the same thing. So all I did was substitute in a +1 for x and a -1 for y, and I get a +2. Since this is our point and this is our slope, using point-slope form, we get y equals 2x minus 3. Then this is f of that, so I'm just taking 2 times 1.1 minus 3 is giving us a -0.8. All right, and then for part C, we actually want to solve the differential equation for the initial condition f of 1 is equal to -1. All right, so we start here. We definitely want to use separation of variables, multiply both sides by y and then by dx. Take the integral of each side, so we're going to get a y squared over 2 plus 1 constant equals a -x squared plus a second constant. Combine those constants, but here we do have a square root to take care of, but the initial condition f of 1 is equal to -1. So I'm substituting in a +1 here equal to a -1, taking or squaring both sides here. So I do get a -2 plus our constant, and then we get a constant that's equal to 3. Now, if y is equal to plus or minus, that could be the case, but here to contain the point 1, -1, we would need it to be the opposite. So we're looking at the opposite of the square root of -2x squared plus 3. So again, take your time if you weren't sure how to go through those steps, work them out again, rewatch the video to help you out. All right, so I do have a free response question on the next page, but over the weekend as well, I want you guys to go back, look at the previous videos to prepare for your Chapter 6 test. I will type up directions for that in addition to this video, which I have posted for today. All right, so please take a look at that. Let me know if you have any questions. Here are the problems. Free response question for today. Work on it still into next week as well. So here are 2 graphs. I will post this as a separate PDF as well, so you guys don't have to just keep watching the video, and there's quite a few parts with this. All right, so enjoy your weekend, guys. Prepare for your Chapter 6 test. Let me know if you have any questions.